Okay, this is solving equations part 3. So we are still working on the performance indicator or the integrated algebra standard, solve all types of linear equations in one variable. And the question today is, how do we solve equations when we have variables on both sides of the equations, or of the equation? All right, so you want to pause the video and do the do now problems. If x over y is equal to 1 and x plus y is equal to 10, then evaluate x times y. Okay, so hopefully you've given yourself a chance to do the do now problems, and I'll go over them now. If x over y is equal to 1, what do we know about x and y? We know that, one thing we know, you may not have done it this way, but this is the way that I want to do it. This is the way that I think about it. So if x over y is 1, then we know that x is equal to y, because that's the only time that would happen. All right? And if we know that they add together to get 10, then we know they must be 5 and 5. Those are the only two numbers that are the same number that add to 10. Right? So if x is 5 and y is 5, then their product x, y must be 5 times 5, which is 25. Okay? Okay, now if 3x plus 5 is equal to 7 and 3x plus 10 is equal to 2 plus y, then we got to figure out what y is. So you might want to pause the video, try this on your own. So what I would think of doing maybe is solving this equation here. And so I'd subtract 5 from both sides. I'd have 3x is equal to 2. And then I'd divide each side by 3 to get x is equal to 2/3. And then I would say, okay, I'd put that back into the equation right here and try to solve it for y. So if we know what x is, then y is the only variable left in this equation. So we'd have 3 times 2/3 plus 10 must equal 2 plus y. Okay, well 3 times 2/3, put that over 1, and then actually the 3's cancel, so you have 2 plus 10 is equal to 2 plus y. So 12 is equal to 2 plus y. Subtract 2 from both sides. Y must be 10. Okay, and if you put that back in the equation, okay, 2 plus y is 12, so that's how it would be 12. And then this would be 3 times 2/3, which is 2, plus 10 is also 12. Okay, this is our first example of an equation with variables on both sides, and you may have seen this before last year. But the way that we solve this, so remember, we always ask ourselves, is there anything to clean up on the left-hand side or the right-hand side before we start trying to subtract or add or multiply or divide from one side to the other? And the answer here is no, I can't add those two things together, and I can't subtract those two things together because they're unlike terms. So now I'm just going to start looking at what I can do from one side to the other. Okay, now the first thing that you might see is there's a 3x on this side and there's a 9x on this side. All right, so, and there's a constant here and a constant here. Remember, our solutions take the form of x is equal to something. So we want all the x's on one side, and we want, this would be some constant here. Okay, that's how we know we have a solution. So either I can take the 9x away from one side, or I can take the 3x. Now I'm going to choose to take the 3x, and I'm going to get rid of this because it looks like a fraction bar. I'm going to take the 3x away, and this is why I'm going to do that. Because if I cancel this here, I have 7 here. This right here is still positive. That's still positive 6x minus 10. Okay. Again, you could have done something different. You could have started your first move by taking 9x away from both sides. Okay, maybe I should show that move. Maybe I should show an alternate way of doing it afterwards. So let's see here. So this was taking 3x away. Okay, and now we have 7 is equal to 6x minus 10. So let's add 10 to both sides. That's 17 is equal to 6x. Okay, now we have to divide by 6. Divide by 6. X is equal to, now we can, let's just leave it as 17 over 6. If you want, you can turn it into a mixed number or a decimal. 6 goes into 17, what, twice, and then 5 over 6 remainder? Or, I don't mind if you leave it as an improper fraction. Okay, another technique for doing this is, I'm going to do it over here on this side right here, is instead of taking the 9x away, or taking the 3x away, I could have taken the 9x away. So if I had 3x plus 7, is equal to 9x minus 10, right? I could take the 9x away from both sides. Oh, actually, I couldn't do that yet. I'd have to use keep, change. I guess there's lots of different ways. I could have also added 10 to both sides. Let's try that move. Let's add 10 to both sides. So let's actually just do it under here. Okay, so if I add 10 to both sides, I want to add it over here because if I put it under the 3x right here, I couldn't add 3x and 10 together, so I might as well not just put it underneath the term that it can add with. All right, that cancels. I have 9x is equal to 17 plus 3x. Now I can subtract 3x from both sides, and I'm going to get the same thing. I have 17 is equal to 6x. If I divide each side by 6, I get 17 over 6. Now, finally, the third way you could do it is you could subtract the 9x from both sides. Okay, but before you do that, you have to use KCC to change the subtraction into addition, because you can't just take away the first part of a subtraction problem. Okay, now you can take away this 9x, so let me do it in a different color here. You can take away 9x from both sides, and that's perfectly fine too. What I'm saying is you don't have to, you're not making a wrong choice by taking away 9x. So you have negative 10 left over here, that cancels. And then this is negative 6x plus 7. And now if we subtract 7 from both sides, we would get negative 6x is equal to negative 17. Because remember, negative 10 minus 7, use keep, change, would be negative 10 plus negative 7, which is negative 17. All right, and look at what happens when you divide each side by negative 6. Okay, you'd have x on one side, and you'd have x on one side, and what you'd have left on the other side is, remember, you'd have a negative divided by a negative makes a positive, so you would just have 17 over 6, which is what you had before. So as long as you're using inverse operations to get rid of, and you're using the correct order of operations to get rid of, use the SADMAP, then you're not ever doing anything wrong. You just arrive at the right answer in a different method. Okay, the next practice problem is a little bit more tricky because there's things I have to do to either side in order to be able to add and subtract from both sides. So remember, I asked myself, are there like terms on either side? And the answer here is yes. Okay, there's two constants that I can add together, and there's two terms with b. But the first thing I want you to do is I want you to change everything to addition. Okay, so I want you to use keep, change on both sides. Keep, change. Remember, when we have subtraction in a row, we can just keep going. And over here, I want you to go keep, change, and then that will make it 3b plus negative 10 plus negative 5b plus 8 is equal to 2 times 6b plus negative 22. Okay, now since I have addition, I can add those two together because I could consider them next to each other, right? That's the commutative property of addition. And when they're next to each other, I would add from left to right. So that's negative 2b plus negative 2, right? Negative 10 plus 8 is negative 2. And that's equal to, let me take away that. That's equal to, now over here we have to distribute. So this is 2 times 6b plus 2 times negative 22. Okay, so I'm just going to keep this here. And that's 12b plus negative 44. Okay, now there's nothing to clean up on the left-hand side. There's nothing I can do to the right-hand side to combine like terms, so I'm going to go ahead and start working from one side to the other. Okay, now there's plenty of things I can do here. I could add 44 to both sides. first, or I could add 2 to both sides to get rid of it on that side, or I could add 2b to both sides, okay, or I could subtract 12b to both sides, okay. So what I generally like to combine the terms with the variable first, and I often like to try to be strategic about it so that I don't end up having to subtract a negative from another negative, which I would, if I did minus 12b, I'd have to subtract I'd have to subtract a positive 12 from a negative 2. So I like to be a little bit more strategic about that, and I like to choose to make things look more positive. It's easier for me when, and probably for you too, when things are positive rather than negative. So I'm going to add 2b to both sides. I'm going to add the additive inverse of that term. 2b is the additive inverse of negative 2b. So that cancels to get 0. I have negative 2 is equal to 14b plus negative 44. Okay, notice I made these end up being positive, where if I had subtracted 12b from both sides, I would have had a negative 14 on the left-hand side. All right, and then I'm going to subtract, let's see, I want to add 44 to both sides, right, and I'm actually going to have to erase some of the stuff up here and bring it up here to finish it off. So let me just erase underneath here. Okay. So I have a little bit of room. Okay, so let's just bring down. So negative 2 plus 44 would end up being 42. That's equal to 14b, and that's 0. Okay, so now we can just divide each side by 14. Divide by 14. We'd have 14, let's see, 28, so that would be 3, right? Is 14 going to? See, 14 times 3 is 12, and that's 42. Okay, so it's 3 is equal to b is your final answer. Okay, now our next problem actually, it looks like it's a little easier than the last problem. So again, ask yourself, is there anything that you can do to clean up the sides before you start adding and subtracting from either side? And on the right-hand side, I can't add those two terms together, so that's all set. But on the left-hand side, I can distribute that 2 in. So let's go ahead and do that. That would be 2 times 3b minus 7. Oh, no, I made the classic mistake. It'd be 2 times 7. Oops. That's equal to negative 5b plus 30. Now that would be 6b minus 14 is equal to negative 5b plus 30. Okay, there's nothing else I can do to clean up the left-hand side or the right-hand side, so I'm just going to go ahead and start adding and subtracting from both sides. Now, again, I like to start working with a variable. Maybe you don't like to do that, so you can do something a little different. You can add 14 to both sides. You could subtract 30 from both sides. You could add 5b to both sides, or you could subtract 6b after. You could only subtract 6b after you change that side to addition. So if you really are into doing that, then you can go ahead and do that. But I'm just going to add 5b to both sides, because for me, that makes it positive 11 on the left-hand side. And I like working with positives. So 11b minus 14. Okay, and then I'm going to add 14 to both sides. 11b is equal to 44, and divide by 11, and then b is equal to 4, right? And then you could always, to make sure that you're right, you can always put it back into the equation. If you just run it through, if you have a 4 here, that would be 12 minus 7, which is 5, times 2 is 10, so the left-hand side would be 10. Negative 5 times 4 is negative 20, plus positive 30 would also be 10. So that's just verbally running that through this equation to make sure it works. Okay, and then we just have one last problem to work on for the lesson. Now, this one we have to be a little careful because there's lots of, this is a negative sign, there's a subtraction symbol, there's a subtraction symbol and a negative sign. So my first move, I really like to do this as my first move. I want to change everything to addition. Okay, so I didn't give myself a lot of space on the top here. I'm going to use keep, change within the parentheses here, and then I'm going to use keep, I'll do it underneath, keep, change right there too. Okay, so -2 is still on the outside, and then I have x plus -5 is equal to, okay, keep the 4x, I change that subtraction to addition, and I change the -7 to a +7. Okay, and then I want to make this side a little bit, I want to simplify the left-hand side before I move on, so that's -2 times x plus -2 times 5 is equal to 4x plus 7. Now this is -2x plus, now this would be -10. That's equal to 4x plus 7. Again, I like to try to get the variables combined first, and I also like to try to make moves like this move here that would make it positive. Because if I subtracted the 4 from both sides, let's try that. On this left-hand side, I'd have a -6x, which is perfectly fine. It's not a wrong move to make. I just like to choose to make moves that make more of my numbers positive rather than negative. All right, so let's just add 2x to both sides. Okay, cancels it here. Also, always just make one move per line. This is one move. Don't try to, add 10 to both sides while you're adding 2x to both sides. That's not, or subtracting 7. You're going to end up making mistakes if you do that. So take your time on these because you don't want to make a mistake. Okay, and then let's subtract 7 from both sides. So I have 6x is equal to -10 minus 7 is equal to -10 plus -7. That's equal to -17. We had an answer similar to this at the beginning. So divide by 6, and x is equal to -17 over 6. I believe the first slide we did was 17 over 6. So and I think we changed it. It was -2 and 5/6. Okay, so either answer is fine. You can leave it as an improper fraction, or if you like to change it into a mixed number, that's also fine. Okay, so that's the rest of the lesson. Your homework is page 3 of problem set 2. Okay, and that's up on the website if you need to find that.